Hey, this is Coffee Compiler Club here today to talk about compilers and whether or not NP complete algorithms are a bitch to code on. So our register allocators and type systems and every other thing on the planet related to do with language implementation design. I just grabbed Derek here. Let me find Derek, and then I have three new people today. So I'm going to ask you guys to go give me the 10-second summary, and because I'm going in order on my screen. Timothy, you're first.
Hi, I'm Tim. Yeah, it's my first time joining the club, although I met Cliff a few months ago in the Bay Area. I'm interested in compilers. I'm working on a JVM implementation right now targeting WebAssembly. So I'm trying to like JIT Java bytecode into WebAssembly and then have a JVM run in the browser.
That's one of those, damn, good luck with that. Corey.
Hey guys, I'm Corey. A little under the weather due to kiddo germs, but yeah, I come here from kind of the offensive space. I've been using decompilers for a few years, haven't really known how they worked. Working through the simple implementation on my own in Rust. Hopefully to one day have a decompiler of my own to lift binaries into pseudo C.
Excellent. And I would love to see what you end up doing with nodes and edges for Rust, because everyone who's done a Rust thing has started out by bitching that this is really nasty to do in Rust.
Sure, yeah,
But
happy.
there's hopefully a better answer.
We'll see, we'll
Okay.
see.
Yeah. Apo. Apo.
Yeah, that's hi. I'm Arpo. I'm also one of those Rust folks, and I didn't start with pitching. I started with doing something completely different. So I'm writing a JavaScript engine in Rust, which is because Rust will not allow you to do the normal pointer stuff. I'm doing everything in just indexes, which makes for very interesting things. And I'm not doing JIT for the foreseeable future, but I'm very interested in GC and well, interpreter implementations and so on.
Yeah, welcome.
Excellent.
Um,
Welcome, guys.
I don't have any normal set agenda. I can talk about what I was doing this morning, but if anyone has questions they want to ask, this is like a good time to go ask. And Arthur pokes up. All
I
you,
can
yeah, go for it.
I can kind of well try. So as I was saying, I'm writing a JavaScript engine in Rust with just indexes. Like I don't have pointers basically anywhere. Um, and my my heap, my arena of my GCable arena is then just a collection of vectors where all the vectors contains other references or other indexes to other vectors. And then when I do GC, I just do a normal mark and heap or mark and sweep algorithm on that, tracing algorithm on that. But I've been wondering, like, is there any kind of has this kind of stuff been done before? Like, it's not a very weird idea, particularly,
It's been done
but I
before.
haven't really seen it much.
So the C2 implementation in Hotspot has node structures and pointers to other nodes. I don't have to do indices everywhere. It does have indices because there's lots of uses for those as bit set vectors and things going on. That also happens. They're grouped into an arena. Periodically, I declare the arena is, too busy with whatever other things going on, and I walk the nodes and edges and copy them to a new arena and then recycle the old arena. So other than having indices for everything, yeah. And I did this 25 years ago, and I wasn't the first then. This one's been around the block a few times.
Yeah, I'm rather wondering about the indices for everything, put everything into vectors and so on.
No, all the old school algorithms don't do pointers. They all start with indices for everything.
Okay.
I will say that Rust C, like the Rust compiler, does essentially what you do. So if you look at their source code, they have like a basic block indexing into some arena of like allocated data. So yeah, it's they don't use pointers or some unsafe thing. They just do
Yeah.
it.
Indices. Yeah, you have to ask, you threw away one of the major supports that you get out of a programming language when you do the indices everywhere. There's no type safety on the index. It's just a
Agreed.
number,
Yeah.
right? And isn't
I
this
mean,
like defeating the
you
purpose?
you can just create your own typed index. That's what I do. Like I have all of my indexes are
Can
strongly
you
typed.
have type indices that say I'm a call or I'm a region node or I'm a fee function or I'm an add or I'm a float op or I'm I get pointers that have like types to them and the types say something useful.
I mean, why couldn't you in the end?
Well,
I
I
mean,
don't know
at the
enough
end of the
Rust.
day, a point like I
Yeah, I have
don't.
a Rust index. I declare it a call Rust index. And then there's something I do with it that says I can get call-like properties out of it. Like I can ask it questions. Who's my target? What is my calling convention? How many arguments do I have? What's my function return? These are things I can ask out of a call pointer that I have. And
Yeah, I guess the only difference with going with a pure index is then that you need to actually know like what you're pointing into. But after that, then
that's
it's
what
all
I'm
the same.
saying. How do you do that? How do you answer that question? Exactly.
So basically, I have a pointer to the arena that is going through the call stack all the time,
Yeah.
and then every index will like anything you do with an index will always basically take the arena with it. So
But
if I need to look at
okay.
let's say the string data, then give me the arena, and I will give you the string data.
So from the index and the arena, you can get basically a typed object of some kind. You do an arena
But
lookup.
then it's essentially you are passing a deconstructed pointer where you have a base and offset. Like
Base
what
and
are you
offset, yeah.
gaining by this?
If you're gaining that you pass the Rust type checker or borrow checker.
But that's
Okay,
one thing,
okay.
but also it's much smaller. So I get to deal with 32-bit values
Yeah.
instead of 64 bits.
Well, you don't have to have 64-bit pointers everywhere. C2 did 16-bit indices for everything for a long time, and then a bunch of people really wanted even more inlining, and I would routinely run out of, not routinely, say one compile in 10 would run out of 65,000 indices, and I'd have to switch. So we just moved it over to 32-bit indices, but it never went to 64.
Could have been the
Yeah,
index. The indexes could have been the relative offsets. So you have reached some point, and all the other nodes are relatively numbered after it. Wouldn't that create it?
I mean, I had 65,000 unique ones.
Yes.
Hey, Yasser.
So-
But that they're already unique. I don't know what you mean
Oh,
by
okay,
relative
yes.
now.
Yes. You won't be able to uniquely identify them.
Okay.
Yeah.
No, you could have pointer offsets into an arena as opposed to indices into an arena that's basically an array that you've scaled by the indice. I assume that's what you're doing when you say an arena and an index. It's some sort of scaling.
Yeah. Or in my case, it's the arena is a collection of vectors. So
Yeah.
and then the indexes are typed, so they know which is if we don't know the exact type, then there's a tag and an index, so we know
Right.
which vector to look into and so on.
Yeah. So if I use this with a C++ version, when you say tag, I add vtable. That's my type tag. So I get a typed object, right? So I have an arena. It has node objects in them. There's 50 varieties of node objects. I need a tag to tell them apart. The tag is the vtable that comes with C++.
Yeah. In a normal or a traditional engine, yeah, that
In
would
the
be how you
traditional
put
set,
it,
right.
Yeah,
So I'm just mapping
yeah.
one-to-one the data structures you're using, and I'm
Yeah.
claiming that it's still like I'm eyeballing it. Like I get a lot of
So-
support out of this stuff.
In my case, one thing that I would kind of point to as a benefit is that I don't need to have vtables in the heap because they are in like all the vectors are kind of known. Like this vector only contains this kind of stuff. So once I get to indexing that vector, now I already know what the type is statically.
Right. Well, you have to have some entry point. If I give you an arena and an index with nothing else, it has to be able to find a tag right away. Once you find a tag, it's tag to tag. You already know type to type to type.
Yeah, so the index, like if it either it's a statically known index, like a statically known typed index. So let's say like this is the an index to the vector of strings type of thing. In that case, like it's just a 32-bit integer.
But you don't have
If
to
it
cheat at Rust to lift it to a vector of strings. Given an arena and an index, and you know the index is just to the string array, don't you have to
so
go to
then it has a separate type. Uh, it's a separate type, which is a 32-bit integer in the background, and it has a method that will then
you've
read into the
maintained
arena.
the type info on the index that
Yeah,
it's to the vector strings. Oh, okay. Okay.
yeah. And then if it's like any value in a JavaScript engine, then there is actually a byte of tag, like tagged. It's a tagged enumeration, and then I can kind of use switch on the tag, and then
Yeah.
you kind of get the
Right, right.
data,
Well,
or like the type index.
in the land of C++, you do a vcall on the vtable, which is switch on the
Yeah.
tag. Done. Yeah. Okay. Okay. So you at least retain some type info. I was thinking you lost it all.
Now I keep it all.
Well, you can recover it all. That was the question. But if you had to recover it at every step, it kind of seems like it would be a bitch to code to. But okay, fine.
So do you have like a separate index then for every distinct thing in your compiler?
Yeah.
Okay. And then that tells you when you indirect it or when you get it back from the arena, that tells you what you're going to get. Is that what you're saying?
Yeah. So like if this function returns an object, then it returns an enumeration which is one kind of object. Or if it returns an array, then it's just an index into the vector of arrays.
Hmm.
One thing that I'm kind of hoping that this will make very beneficial or fast, basically. It's at the end of the day, it's all about performance, isn't it? But one of the things I'm hoping is that basically because I have all the stuff in vectors with their own types, or with types of some kind, then that the cache locality will be much better because usually you're looping over similar values.
If you're looking for that much level of speed, then yeah, size is the win. Yeah. C2 for, I'll say most sort of small to mid-sized compiles lives in an L2 pretty easily. And that's one more step of speed.
I feel like direct pointers though are going to be more cache friendly than vector arena, right? Because you're just going directly to what you need.
It's the struct of array versus array of struct things, and sometimes one or the other, depending on your access pattern. So a lot of the old school integer algorithms, vector pointer algorithms, all ended up accidentally, on purpose, whatever, being struct of arrays. I had an array of this, an array of that. I still do that. If I only have a couple of things I'm grabbing, I throw down a couple of arrays. When I get to like 4 or 5, I'm like, this sucks. And I switch to an array of structs and quit dealing.
That's honestly something like Rust has some good macros and so on, but I don't really use a lot of those. So I'm really looking forward to a day when somebody gives me a really, really nice, maybe preferably like compile time, nice compile time struct of arrays library. I know there is one, but it's not quite perfect. Zig, I think, has the multi-array list, which would make this like really, really nice. You can basically just take like, this is my struct, now make it into a struct of arrays, and it works the same way.
Keeps the same API somewhere, somehow.
Yeah.
Yeah, okay. Yeah. Yeah.
The
manually faked it a couple times on different language setups, but there's no general purpose library or whatever. Like I don't have a general purpose library for that.
Probably like compile time reflection would be really necessary to make it actually like nice to have or like
When I did it
convenient.
for H2O, big data thing from a decade ago, it was, in fact, compile time reflection and class for name. I built a Java class file to mimic the different things and ran it through the JIT and all that.
Yeah, I figured Java would probably be a language where this would be actually like nicely feasible since you actually have the compile time reflection.
Yeah, I won't claim it was easy, and it wasn't. Certainly, the API I got out was not perfect, but it was, I want to say boilerplateable. Like you used a little boilerplate to use it, and you had a little bit of this or that, but it looked reasonable enough, and reasonable enough that I could get mathematicians to write big data code that would run on terabyte scale things. So it was, as far as I was concerned,
Nice.
that was a win. Okay. Anything else? Something else on before we move off from Rust, and I'll bitch about register allocators just to change topic, but for no other reason. So I'm hacking register allocator for simple. It does an okay job much of the time. I don't have a lot of test cases, so that's kind of a lie. I can't really tell you that it's doing a great job or not. And then Nick on Discord says, here's a trivial test case where you have a back-to-back copy in copy out register, and why the hell did you do copy? And I was like, oh, I've seen this before. I know what's going on. I can go fix this. And of course, it's an NP complete problem. And so you always answer it with statistics, not with single use cases. So I fixed the one case. And then I ran my test suite, and sure enough, everyone else loses and this guy wins. And it's like, oh, shit. And go, what do you go do? And why are they all losing so bad? And this thing's stupid. And what's going on here? And so I'm in the middle of the whole, why does this minor change cause all these other guys to lose? And then from there, if you want more details, I'd have to go pull up something to go demo for a while. And it's hard to follow because it's in the middle of the register allocator doing its complicated shit. So that's what I spent my morning on, and that's why I was slow getting the links out. Yeah. All right. Somebody else's turn.
What would be the approximate quality of the register allocation?
Oh, at the moment?
Dash wise, yeah.
Oh, it's very hit or miss. I don't have enough large test cases to tell you. So, I mean, I know you're trying to prompt me to go there, and I'll go do it. So I'll do this thing. So hang on. I have to hit the view. Hello, view. And then it's like IntelliJ is just, there's so many stupid things that they made stupid in the years since I've been using it that if I just got rid of them, it would be there. For instance, that one, it just undid the view change. I don't understand why. It won't hover, light up. It won't take the view. I'm trying to get the zoom in. Okay. Now I can go to Discord. No, Discord. I go to Zoom, hit the share button maybe. Yeah, okay. So where is a bad good test case? So here's Newton's on a square root using integers. The main trick with it is it carries a loop carry dependency so that the guess value is carried around to the next iteration. And so you must have at least one copy. In fact, it's difficult not to have two. I think this one worked out and the float guy is now sick. But I did a bunch of things this morning. Is this readable?
Yeah.
Yeah, okay. So here after the hack that fixed the nasty case, which I didn't show, and I didn't show why it was failing in the first place, so it's hard to tell what's going on. Okay, so the Newtons and the square roots is okay. There are two copies in the body of the loop. Copy to rax and copy to DI. So you bring the original value in, and it's a DI, move to CX. I'm not sure why. Oh, it's probably crushed by the div or something. The div crushes a couple things. The div actually crushes DX, I think. So anyhow, you get your guess. You take the original value and copy it here. That's one of the minimums. So then you divide the original x by your guess. You add the guess. You divide by 2. And you see if you're equal. And if you are, you win. And if not, your guess is now in racks. And he wants the guess in DI. So you get one more copy and you go around again. I'm not certain if I can do this with one copy. I think I can, especially if I roll the loop, I could probably get it down to one copy. But fine, it's reasonable. The calling convention down here is, I don't have calling convention enabled. That is a separate, unrelated, it's just not done. So you get to cheat at the calling conventions. But he moves, RDI, it's already there, so he could call square root. Returns in racks, puts it in CX. Adds 2 because that's the test case just to screw with you, and then he calls it again, and he adds the 2 in return. So this is actually pretty reasonable. Go look at the float version. Oh, hang on. Oh my goodness. Well, here's Heinz. So here's all kinds of spilling things I turned on. Let me go down here and look. I had debugging points. Hey Heinz. Long
Hey guys,
time.
how's it going? It's been a while.
It's been a while. Yeah.
Yeah,
You are.
I always log on at the wrong time, and then it's like, oh, the meeting has finished already. It's like, oh, dread.
Well, it's got
Let
to
me
be
try
some
again.
ridiculous hour in the night for you.
No, it's not too bad. It's like 8, 8:30 in the evening.
Oh, okay. All right. Yeah, fine.
Yeah.
You're in the same time zone as I am, then.
Yeah. And
Where,
then your
where are
kids are
you?
all like mostly
Finland.
grown up or teenagers or something now, late teens.
Yeah, yeah. Well, the one is a preteen. She's
Oh,
11. Effie, you know Effie, of
yeah. Oh,
course.
yeah. 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 I guess can't keep
Yeah,
the ages straight. Mine
yeah.
are
And
all
and
approaching 30.
the rest are supposedly adults, right?
Yeah, 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 yeah. We don't ask those questions. Well, okay. Yeah, we have our second granddaughter coming, grandson maybe coming right
Yeah,
at
wow.
it's in between J-Crete and Burning Man.
Oh,
And so we're
wow.
like trying to figure out how the hell to squeeze that all in together.
As long as it's not your own kid, it's okay. You know, you can miss that sort of a little bit.
Yeah, but this was specifically Lisa's daughter asked Lisa to come help when the baby's born.
Okay, so it's Lisa's daughter. Okay,
It's
that's
Lisa's
different.
daughter, and Lisa's daughter
That's
asked,
different.
yeah, I'm the guy. No, Lisa's the
No, that's
grandmom.
different. That's
Mom
different.
asked
Yeah, yeah,
grandmom to
yeah.
come help.
No, no, no. Yeah, she has to. There's no
Well,
excuse.
okay. So then we have the time getting back from Crete, getting her to Philadelphia, and then
Yeah,
I'm
of
probably going to
course.
go to Burning Man solo, and she's going to show up a week late. And it's just like, oh my God. And she's staff at Burning Man. So it's a mess right now. Fine. So
Oh,
unrelated to
too
anything to do
funny.
with compilers, we were just looking for a change of topic for compilers. I was going to talk about why registrar allocators are being why being NP complete is a bitch. It's unrelated to anything else. So you got anything you want to ask or talk about?
No, I just wanted to say hello and watch what you guys are up to.
Watch what we're doing. Yes. Well, we bunch of guys here doing ports of this and that to sea of nodes related things. Half of them are in
Okay.
Rust, half of them are targeting browsers or JavaScript in some version or another. So there's some three-way. I'm a compiler, I'm a Rustian, I'm a JavaScriptian browser thing. So
I
fun.
saw in the notes there's like some stuff about JavaScript engine and Rust with indexes instead of pointers.
Yes. So it's
Yeah,
Rust.
that would be me.
You can't do. You're not the only guy, Apo. Yeah, there's like 3 people doing Rust, and they've all gone the route of I made a giant a collection of node objects, structs, pointers, something, and it can only use
Okay.
indices. So it's base plus offset. It's the arena base
Yeah.
plus the index. That's
Okay.
how I sidestep the borrow problem. So there's no allocation within the arena other than bump
Okay.
pointer within the arena.
Okay.
So in my head, what you've done is you've given up on all the good things that come out of like types with pointers and virtual calls or C++ or Java casts and knowledge about whatever in exchange for I'm only allocating things in an arena so that I can just throw the arena away. But I do that in C++ with that. I mean, that's C2's design. So, there's no call for doing this in Rust directly other than it's, whatever the new thing Rust is. And C++ has its own issues. We don't have to go there. I'm not defending
A
it.
big array where you look stuff up by index is the preferred way to put use after free back into Rust.
Yes. Yes. Exactly. Or I could talk about register allocators and why it's a bitch.
Yeah.
Well, this is the bad version of the float guy, who's just the same as the integer guy, except he's floats. And in his hot inner loop, he's got 4 spills up from 2, and they're all over the map.
All of the move instructions are from the loads and stores.
Yeah, all the moves are from spills.
Okay.
These are all spills. That's the spill. There's the one on the back edge that the integer version has. There's one on the front edge that you think the integer version ought to have. One of those two has to be there because it's a loop carry dependency. Then there's 2 more, and they're like, no. Why are these here? And this was all because I had a stupid extra copy. I wonder if I could go unwind and turn off the bonus things I did just this morning without losing. I could stash the changes and we'd go again. What did I do this morning? I did something else useful this morning as well. But no, that's part of the thing. That's just a bug in the x86 port that'll just come around. This is part of the other. I think I can just unwind. I'm going to stash these things, and we'll go look at what happens if I don't have them. And then you can be like,
I'm curious how big these graphs are and if there would be any use in looking at the graphs visually.
yeah, these graphs are small, and we can just go look at them visually. So, oh, you mean as a graph viewer graph?
Yeah.
Boy, it's been a while since I pulled out the graph viewer.
I don't know if there'd be value in it for this case, but
No, there could be. What do I have here? Isn't there a show graph? It's probably under, where did I put show graph? It's been so long. You got me confused or like, wait, I did this. This used to work. And I thought I had CodeGen code had show. There's the show, system.graph visualizer, this thing. Okay, this is not the best way to go do this. New graph visualizer. Oh, I have to go throw that, but I could do this. Why is graph visualizer choking on me? Code.stop. Yes, class not found. Graph visualizer is in the, yes. Why do you even ask, IntelliJ? No, okay. He has to import the class. Alt-enter. Yes. Yes. Why did you even ask this question? This is like IntelliJ being stupid. I'm really bitching at IntelliJ recently. He's gotten so bad. Okay, I have to change how I view this. So we're going to stop share. We're going to pull up this guy. We're going to pull up online. Oh, Carno map solver. You guys didn't. Yeah, how many people know what a Carno map is? GraphViz viewer. There's green puff, GraphViz. Select, paste. Something happens here. He says syntax error line 57. I probably have a print bug. That's been a long time. Yes, I have a fucking print bug. Let me share anyhow, and then I'll debug. So I haven't done this in so long. It's got a little tiny bit of bit rot. I'm hoping it's a little tiny bit of bit rot. You're gonna give me another syntax error. 119 is probably the same one done over again. And then 126, let me go to 119 again. I typoed that anyhow. No, 126, yes. EQ. 123. Oh, here they all are. EQ, oops, fingers off. How about now? How about now? I missed 1 or 2 more. Yes, 165. So this is like I can go correct this almost faster and then rerun. Oh, well, there's this graph. kind of a mess. This is me typoing so that you can ignore that guy. What the hell can you read
This
out of the graph?
post-spill?
I'm sorry?
Is this post-spill?
Post-spill. There are moves. I
Okay.
can also bring up the other graph viewer for the online peephole optimizer, which will not go post-spill, but it will give you color codings on things. But we can piece this apart. So here's the start for main. Main has an incoming argument. There's a default call, which is I take anything from arg. He points to start, and then he says, convert my int to a float, move into a register, make a call to square root. Also bring it around, add to, move into a call for square root. Then I have two square roots, one at arg and one at arg plus 2, and add them at this guy and return. So that's the whole left-hand side of the graph. That's not the part that has spilling issues. So here's the right-hand side. So here's square root. He takes a float arg x. He got some copies at the beginning. He has a guess. The red edges are mostly ignorable. They just say, I'm in the body of the loop with the sole specialty is the jump, which I typoed when I typed on the left, was comparing for guess is equal to next, and I'm done, and then I would get out. That's this one where he has this equal here. So this should be pointing to this. And he says, take one of the exit values, and I'm done. Otherwise, I have all these moves, and this is the bonus extra junk moves. It's because I need to take the divide, has to take the original value x from outside the loop and divide it by guess. And then he has to add guess. So this has to bring up the divide plus the guess. Then he has to multiply it by half. There's your divide by 2. Then he compares. Then he goes to the back edge and says, bring it around to guess and go again. So this is the graph version. And you see, of course, there's like move, 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 divide, and then move. There's like way too many moves. And furthermore, the moves are completely junk. Okay, this is after I did an unrelated change that I thought was like very minor to fix up an unrelated junk spill situation. So I can, from here, you can ask questions. I can unwind my hack of this morning and produce the spill code for this that's nice, and then show you the broken spill code. And then you can see, oh, NP complete, here I am, what the hell's going on? And why is this one broken, the other guy fixed, or that one broken, this one fixed? So this is the NP complete whack-a-mole issue. So from here, I'll poll the audience. Ask questions. If you ask them now. Otherwise, I'm going to attempt to unwind and show you the fixed version of this, and then the broken code, which is much, much simpler, and show you why it's broken and why I thought my hack of the morning would be like, fix this thing and no problem.
I guess the question that I have is going to get to the thing that you're about to do anyway, which is what's the heuristic that was putting those moves in?
Okay, so that's when I'll start by leaving things broken and show you the heuristic situation. And this, by the way, is different from what you and I did earlier. And this is the better version in that it's way more accessible and how you debug it. It does the same strategies for putting the same spills in, but it's way more accessible and understandable how to split. This is my new love for how to do splitting in an allocator. So I'm going to kill this, and I'm going to go back to this guy, and we are going to go look at this guy and say regalloc. And regalloc comes to regalloc comes to regalloc. Okay, so the start of the world, there's the split of the world, and there's post, and post color just gets rid of junk things. Okay, so we're going to run through Newton float, and after he's done setting himself up. Okay, so from here, I only reasonably have a text view, and in the text view, I'm going to show you things to ignore. So here is main calls call with an int to float. There's the call in. He gets an argument. There's an add of a 2, gets a call. Okay, that's the stuff that works fine. Here's the loop that's the issue. So the loop here says, I have a phi of a guess. The guess 25 is node 25, which is the incoming argument x. And by the way, the 20 and 26, that is when he gets his inputs from his call ops. I can tell you perfectly, I have a full call graph, not just this control flow graph, a full call graph, but fine. So there's guess starts from X. You divide 25, which is X, by 24, which is the guess. So all the node numbers are here. People ask about node indices. Well, here they are in spades. You add the divide with the guess, get a new node 30. You multiply this by 1/2, that's been hoisted out of the loop. You compare to guess, and if your guess is equal to your next, you're done. Otherwise, that thing you just multiplied, the 20, that's your new guess. So he's brought around to the back edge to be the input to the guess. So if you stared at the brought around to the back edge from here, rolled back up to here, that meant that I have a loop carry dependency and it overlaps with guess. So you have to have two versions and you have to copy from one to the other at some point during the thing. So you must have a copy here. It's SSA form, SSA removes all copies. So I start with, I must fail and put copies in. Also, I have a bunch of hard register dependencies that are going to fail me out anyhow. And so I expect some spills right away. So I went to graph color. I didn't step into it, but it's right here. It says, oh, initialize, then build live ranges, build interference graph, color. If any of these fail, I fail out. I have failed. And here's where the new thing that's different from what I've done before. The failures are all here. They're by live range, and I have enough live range data in a struct. So this is where I went from struct of arrays to an array of structs about 2 weeks ago, and I've been loving life ever since. And I can tell you something about live range 8 and live range, 1? Both of them spilled. So live range 1, well, live range 8 is going to be the self, oh, he's not yet a self-conflict. He ran out of registers. He took he has one defining point, at least one defining point. He has two defining points that need a single register. Since his mask is empty, almost surely he got conflicts amongst the defining and using points, and he ran out of registers. There's hard conflicts. Something defined, something used. They disagreed on what register. One of the defining points is a projection x86 number 2 that comes from a call in. I need to have a value, comes out of a call. One of my users is the return. He needs to have a specific register for the return. In this case, if you remember, I have two calls. This guy returns an XMM value. This guy returns XMM0. The return might take it XMM0, but this guy must go around this call, which must clobber XMM0. So the def from the first call just has to be moved. This is a hard fail, must move this guy. So, okay, there's one of my failures explained. Here's the other failure. Let's go see why he failed. He says, I have self-conflicts. This is the loop carry dependency. Somewhere in the body of the loop, I simultaneously have alive the original value, the value I would carry in the fee, one of the divs, and one of the mols. And what it means is I need X alive, but I need a guess. So I must copy it to a guess spot. I must have a copy before I enter the loop. But inside the loop, I have more conflicts. And I must have another copy within the body of the loop. So now I have one live range with self-conflicts and one live range with hard register constraints. So let's go into split. This is the new thing. Pick one of the live ranges. So in C2 and in all prior allocators I've ever seen or done, when you split or you spill, you visit the whole program and you ask every def and every use, are you related to a failing guy? And if you are, put a spill in as necessary. Make a decision at every def and every use about why that you're spilling. Here, the new thing that's different is I'm going to say, I have a live range. I know something about why it's spilling. I'm going to do spilling per live range, one live range at a time, instead of for the whole program, check each node, you make spilling decisions. So I've inverted the loop. Instead of saying, for a whole program, check a node, is it a spilling related, do a spill thing. It's for a live range that's spilling, check all the live range nodes and do something. So I inverted a major set of loops. This is what I'm loving. So first live range up, live range 8 here. This guy has, he doesn't claim he has splits. He doesn't have the easy answer for a hard empty mask where I have one def in one register and a use in another is common around calls where you define an incoming arg in a register and you use it in a different register in another call and you just have to split. Here it's because I have multiple overlapping defs and uses that all want XMM0. So he goes to the heuristic split by loop. And split by loop starts by saying, find everybody related in the live range. That turns out to be a lot cheaper than I thought it would be because I only have to visit the connected sets of defs and uses. So if I go look at my thing here, I have a projection on that first call that's going to say, give me this value as the return from the call. I also have to return the end result as the output of the return. So the return takes an input of this live range. And there is a add float. And the add float demands that the input and the output be the same register. So it's the same live range, which is the live range used by the return and the live range that's produced by the call. And that's the hard conflict. So there's all people belonging to the conflict. And now I'm going to do split by loop, which I'm not going to show. But he walks through this set of 3 things and just makes decisions about splitting. So that was split by loop. And now I can stop and look at this program and see what happened here. So split by loop is kicked in down here in my set of calls. And what he said was, the output of this call failed. I have to move it. Then I have a second call. And here I've put the add in. The add is in between the two. And this call will produce a value in xmin 0, which will have crushed this output from this guy and the move that you have here. And then there's an add of those two. One will be xmin 0, one will be in some other register that moves around the call here, and you return it in xmin 0. So I got a move around the call and a move back to, and I possibly can get rid of one of those 2 moves during coloring if I pick the correct colors. But I had 2 spills there. So that was that heuristic run on that live range. And then the nasty one is the second guy. Here he says I have self-conflicts. And self-conflicts have the bonus special feature that under sort of various bad situations, which I totally have test cases for, you just have to fucking split it everywhere. And then you hope to God that you can get rid of most of those splits in the end. But if you fail to split aggressively enough here, you will have, I can produce a test case that will then it will remain self-conflicted, and you'll come around for another round of self-conflict spilling. You will not spill correctly. You will remain self-conflicted, and you'll just you run out. You endlessly self-conflict, but don't make any progress because you don't spill anything. And then he eventually times out and says, no, it's no good. So he grabs the list of self-conflicting things.
Is there a version of that where you know that you're going to try and do it progressively? And I don't know if it makes sense for the case, but
Right.
you try and do the minimum spill, but then you remember that this is a self-conflict from before, and then
get more aggressive. Maybe there's always, it's NP complete heuristics to the end of the world. You can always do something. So another thing that could be done here is to say that some of my conflicts are in different loop nesting depths, and go use the split by loop nesting depth, who will do a more modest split around the inner loops.
Right.
And that might be enough to break the self-conflict. Here I have one inner loop. It turns out that I must split fairly hard in the inner loop.
Yeah. So, my philosophy is I try not to get rid of any of the data that I've sort of figured out. And that's why I'm snapshotting graphs and doing all this stuff along the way. And so my temptation when I see this is to say, oh, I'm creating a split and I've got these nice live range objects. Right. I'm going to attach the live range object to the split. And when I come around later and look at it, I can be like, oh yeah, that's the live range from round 2.
The fail there, and having failed this way, is that when you split, the live range is no longer what it was. And
you couldn't use the live range, but you could look at the old live range and be like, oh, here's the info that I had back then.
Okay, that's weird. So here's the deal. There's no correlation. Also, if you do anything else around splits, which C2 definitely did, you would blend like 2 live ranges became 3, and which of the 2 became which part of the 3 is like undefined. So it's
Right.
not clear to me that there is a one-to-one correlation from rounds of splitting to rounds of splitting. Like if you forced a one-to-one correlation or many to one, so one live range splits, and then I say I have new live ranges, but they all came from this one old live range. It's not clear to me that you could do that.
Mm.
And then if you could, what would you carry over that was useful? And one of them, I guess what you try to say is the new live range has a self-conflict. The old live range also had a self-conflict, and maybe even some of the self-conflict nodes are the same. I need to try harder to split. Maybe.
Yeah. Yes, something like that. Or at least you can store some information on the split saying, here's what I knew, here's why I did it, which is useful to you either for debugging or downwind when you
Yeah,
try to
that
figure
one makes a
something
little
out.
more sense because individual nodes can carry data. Although I blow my live ranges away and reset them for the next go.
Yeah. The thing is that you blow the live ranges away, but you've got these objects and you can keep on using them and
So
you can.
right. So here's part of that though. I'm not certain what I would carry through that would make sense here. When you said partial split, exactly splits by loop does partial splitting. And
Mhm.
he remembers because he observes that the portions that are failing are in ever deeper loop nests until he can't go any deeper. In
Right.
that case, I could split by loop until I got to the inner loop, and then I would say, and I still have self-conflicts. Now do the hard split everywhere.
Yeah.
So I mean, I think I can get that approach for this problem, but the general concept of can I record something and hang on to it? One of the things I do record is that I know that you're a split and I see your def and
Yeah.
your use. And
Yeah.
already I've picked up a lot of information about that. So I don't know
Right.
that a prior live range would tell me something that I didn't already know.
Yeah.
Yeah, fine. So maybe. So this guy, this particular dude here didn't used to split as aggressively, and I ran into test cases where like I had been splitting once after every def, and if you're a fee node, I split once on entry, once on your first input. Um, and then later I went to this mode where he is now where he must split after, and he must split before all paths. No, he doesn't split before all fee paths. He still splits only once before on fee entry. He does have to split around two outer specifically. He has to split after or insert before everybody in case you've got live ranges. So he ends up with like three more splits that I had before I ran into some failing cases. Let me just come out and take a look at how bad he splits here. So we split, and that's the end of all the splits for this round. And we can go look. And what's new and different here is the fee guess remains. He split once on entry. It turns out that's at least minimally necessary because I need the original value of X and I need a guess for the fee, which starts at X. He split after the fee. He's got one because he got a split of a split from somewhere. I'm going to go track that one down. That looks suspicious. Here, yeah, this is a split of a split of a split. So there's some extra split came in here. This one I claim should never have come in. That's interesting. And that's probably from a mistake I did with this morning's hack. Here's the split after, which is also the split before of the addf. That's probably just one split before. That's fine. Here's one split before the molf. Here's one split before the comp. And then there's one around the back edge of the loop, which, why did you get here? You came from there, you go to 21. No, you go to 50. Yeah, I thought I didn't do the back edge of the loop. Okay, so I have one or two splits I see that I claim shouldn't have come in, all on the first round of splitting. That's it. I thought it would be on the second round of splitting. This guy usually goes to 2 rounds because he fails to color something. Oh, he failed to color live range 15. Why is live range? Oh, 15 is unrelated. Yeah. The main loop that has all the spills in it is done and gets a coloring, but something else fails. I probably didn't actually get to the point where I colored. He would have colored if he did, but he didn't. Yeah, he had to do one more split through here. He wasn't quite aggressive enough down there. here in the body of the loop. Here's these three, and this was when CCC came around. I was like going to stare at why this showed up. Like you should never have been there. So that's me being confused about that guy. Fine. And then he's done. He colors. Oh, he gets one more split. What are you splitting? Wonder if he failed to do. It's one more on the back edge. Oh, am I not going to color ever? No, he had to do one more split in the back edge. I disbelieve that one too. But the main loop body should have both colored and I claim biased colored and biased colored most of these away. So biased coloring worked down here reasonably. This value gets moved into XMM2 because it has to bypass the call. Also, it needs to be an XMM0, so you must have a copy here. And you do the square root. And then he moves it off to 1 because this call is doing something in a weird order and probably should commute, and then he wouldn't need this copy. But here's the bring around value, and here's I'm adding 2 for the square root. Oh, no, he copies it into 1 because he's calling around this square root. Now, this copy has to be here. Then he adds 2, square roots again. Now he's adding this and this. Yeah, I think this is actually probably minimal copies. But this guy, oh, this is just disaster copies. Like, what the hell's going on there? So that's the mystery of the morning. The version of it that life gets better on is a get undo away. Let me stash all this. Let me see if I did anything else I need to not stash. That's actually unrelated bug fix. Unrelated bug fix. This is me turning off this extra removal. Yeah, this is fine. I think I can stash all this. Where is stash all changes? Okay. See what happens here. No. I'm just gonna run it in and say what do we got? Yeah, here is the much happier version of the loop. I don't like he's using racks or not the racks, although x86 has a direct copy op. If that's cheap enough, I'll leave it. If it's not, I can bias that away. But here is your guess. The original value is carted off into racks. There's one junk copy here that is the same junk copy that I got called out before on that I was trying to get rid of. That's a junk copy. Then he has a value in guess. And then he says, get the original non-guess value, divide by guess, add guess, divide by 2, compare not, okay, move my guess into my next. This is the copy you must have. And I think because of 2 address ops, you must have 2 copies on an x86. One, because the div doesn't have a 3-adder form, you must have a copy there. And then this guy is identical code, no change. So this copy was related to the one I was trying to get rid of. I have an even simpler version that I threw up here. Third time I can assert. Yeah, breakpoint, thanks. And what did I do? I didn't say new. How about now? Sure. Okay. And then go look. And why did I? Oh, because I didn't do this. All right, hang on. I changed the test to reveal the bug, and the stash got rid of it. Oh, we stopped the allocator. That's better. Okay, what do we got here? We get, wow, move RDI to CX, move CX to RDI. That doesn't look good. Okay, allocation takes a number in RDI. I have to add 4 to the array length, so I have room for the length as well as the byte count. So that's correct. And it's a 2-adder op, so it's forced RDI. So you want it in RDI, and you want this. That's perfect. And you want to allocate there, and you get an answer in racks. That's great. But you need the original length. be carried around, so you could copy it in CX. That's great. What's this copy doing? It's just like crap. So we go again. And I'm going to go, yeah, I'll go once in here so I can go see live ranges things here. Let me make sure I filled yet. Yeah, we haven't failed yet. We're going to fail there. Yeah, it's fine. Okay. So back up, take a look. There's two versions to look at here. This is the just raw node view. And under the raw node view, I have my incoming argument arg. I'm going to add node 12 to arg. That becomes node 11, which goes into the new array as a length. That's great. Here's my store 4. He takes the address from the new array, but he takes 12, which is the original arg. So arg is alive down to the store. Arg is crushed by the add and the new. So I have a conflict I must spill. Nothing surprising there. If I go look at the version with live ranges, because why are you not letting me do that? Hello? This is live range 1. Because I'm a 2-adder op, the output of the add is also live range 1. The allocation wants the add output, that's all fine. But this live range 1 is actually the original arg. So I have a def here and a def and a use of this def. There's 2 defs. I have uses in both. I must spill. Okay, fine. I'm going to spill here. Coming into the splitter, we say, what kind of split am I? I'm a self-conflict split, and that is correct. So I'm going to run through and insert a bunch of self-conflict splits. And this is where Derek's saying, wait, that's too many. Let's go look at how many is too many. And the real answer is not that it's too many, it's that they're structured poorly. So the R got a spill after it. The add got a spill in front of it. The new array gets a spill in front of it. And the store has a use of a prior spill. That's the one that came after. Okay. So what happens here is that this move takes from this move. This move has to pick something other than RDI, so it goes around the new array and is available later. So he picks RCX or something. I don't care what. This move is coming from RCX now. And immediately I have an RCX back to RDI. That's the 2 copies. That's the reason it's failure. If this move were instead to point to what this split points to, which is this arg, then you would bias color to RDI and the spill goes away and life would be happy. And so I put code in to say, if I have a split, here's a split I'm inserting, of a split of a split, just skip the second split. And this would clean up this. And when I do that, the float guy does something slightly different in his shape of his spills, and then he fails to allocate. He throws a whole nother round of spilling in, puts a butt ton more splits in, and then they don't clean up. So here's your whack-a-mole. I made a minor change because I just said, if I put a split in here and it's of a split, just skip it. This one gets fixed. So we go around, we colored, we got done. This is the broken guy when he looks broken. Let's go look at him when he's broken here. Call it this version. And he does this bad thing. And that's because this move is coming from this move. And this move is forced to be not in RDI to bypass the allocation. And there is your, hey, it's NP complete. One good tweak deserves another bad tweak elsewhere. So lessons here, NP complete, heuristics suck. Another lesson is graph coloring algorithms. Register allocators are always done with statistics. You must look at a large corpus of functions and decide that you win or you lose every time you throw in a new coloring heuristic. For me, I grab this thing I'm calling spill scaled. That is spills scaled by estimated frequency based on loop nesting depth. There are smarter heuristics. C2 actually gets real profile data, so this is not actually fake. It's the real thing. But if I run that on my test harness, I outpop all these guys who say, I suck when you do this change. And you're like, well, what the hell am I doing now? So
how profitable would it be to try multiple heuristics and then just choose the best one by some metric?
How long do you want your compiler to run?
Forever.
Right, exactly. Who wants their compiler to run slower? He said no programmer ever, right? So, I mean, there are algorithms out there that do like sat solvers, doing, instruction selection and functional unit scheduling and register allocation in one go. And of course, for loops larger than what you saw on the screen, it's 10 minutes to 10 days, depending on how long you want your sat solver to run.
I mean, it's a little not fair to say who said you ever wanted to run longer, because people do run compilers in dev mode to be fast and then with O2 when they want more performance. Like,
Absolutely.
we do make this distinction of a fast
Yeah.
compiler run and a slow compiler run that we
Right.
want to try harder.
Right. So again, if your compiler build takes a day to build the O2 version, was that okay? Sometimes yes, sometimes no. The other one, by the way, that I saw a lot of, still see a lot of, is that we debugged well in debug mode, and we were all happy with debug mode, and we turn on the compiler and something broke. We turn on O2, something broke. Do we care? No, we just turn it off. We go back. We ship with O2. We ship with debug mode. What's the difference in performance between O2 and debug mode? Well, if the difference is like 2x or less, and I have a certain very broad class applications, I'll fucking suck on 2x and not have unknown mystery bugs out of O2. So one of the fun things that came out of the Java experience was that everything was running in O2 all the time, including all the debug mode things. No, you could not escape O2. You didn't realize you had O2, and you couldn't escape it. Well, O2 got rock solid, and you debugged all your shit on O2 mode, and then, life was good.
Yeah, I mean, there's certainly value to ship what you test and test what you ship.
So I claim that I want to run O2, and I know how to give full debug mode, full perfect debugging, and O2 at the same time. This is the Java experience for 25 years, and this is well understood. So all I want to do here is say O2, okay, but be reasonably quick.
I mean, that's really about the language not having undefined behavior. Because if you have a bug that appears at optimization, then you have undefined behavior, most likely.
Yep. So no undefined behavior in simple. And
I've certainly seen the experience with, say, Rust, that running the debug build or running the real build will give me 50 to 300x speedups. Like, it's not 2x.
Okay, so no, that's interesting. In when I was in
And I don't really know why.
C++ programming, the difference between debug and hotspot was 10x, except that since the Java itself was running under O2 all the time, it was only how long it took you to get the O2 compiled code to show up. The VM was running 10x slower, but after a while, the VM was not the big part of the execution time. But there was a big number there. It was 10x. It was interesting enough. But the other thing was that the compiler C2 is just so fast, even compared to debug mode on many of the compilers we were using. C2 in O2 mode was faster than GCC in debug mode. And like I didn't have C2 to
trick
develop
that I remember
with.
that was occasionally useful. I don't know if you remember the Clojure compiler that Google published to compile JavaScript to smaller JavaScript.
No. But
So
fine.
one of the tricks that they used there was they knew that the artifact that they produced had to be gzipped JavaScript.
Sure.
But it turns out there's a lot of flexibility in the way that you zip things, even though the unzipper you don't control, because that's just the other side doing the unzip.
Yeah.
And they found that by very carefully combining the way the output of their compiler was designed to give you symbols that were the symbols that were in the gzip table while you were gzipping. And by being very careful and not necessarily doing a standard gzip, they were able to let this thing crank on a bunch of different patterns of gzipping that would take about 8 hours. But the ultimate artifact would be enough smaller that if you were, say, sending the JavaScript for Google.com down 100 billion times a day,
yes, which
really saved you a lot because you were able to get that thing down from 1.2 megs to 0.8 megs.
Yeah, well, there's no denying that there are times when you're going to burn time here to save time later. The number,
and that was totally worth it, just because you downloaded that gzipped piece of JavaScript a lot.
Right. So coming from the JIT perspective here, I would rather have faster heuristics that worked well enough, and the debate of try 5 different heuristics and see which one does better. That only means that there's a smarter way to define the 5 that you can get the right one first up. I mean, usually it means I get the right one first go. Here I have something stupid going on. I claim I can go fix without putting in a harness that says try this, try this, try this. So I have examples that flow the other way, where I had the 2 junk copies, and I had the float guy, which had all the copies went in when I inverted it. The float guy also had the 2 junk copies. They just happened to not be in the inner loop. But that just means I can make a slightly different change of a program that would certainly end up with both of them would suck in either ways. But the second guy sucking on the float inner loop tells me I probably have something wrong somewhere that's getting tickled that ought to be fixed. Unrelated to anything. While I was doing this, I found 2 unrelated bugs one in encodings and one in the allocator that presumably would have tickled something else. So, yeah. All right, allocation death. Everyone's looking bored.
Okay, yeah, interesting question. How would generics look in CF nodes?
Generics are unrelated. They're like typing. Are you going to do
yeah,
erasure?
but
You're not. The AA's basically got the generic effect, but it's all on the typing. It has nothing to do with the ICF nodes.
yeah, most of the languages don't go for the final product supporting generics. They're always monomorphized or whatever.
Okay. Yeah.
So how you would go about that the other way to support generics inside the final product?
You mean, and not monomorphized? No, like I said, this is all the typing system.
Mm-hmm.
So the types in simple miss a few key things that make their lives more simpler by a fair amount that I would be using to do generics. AA has I have the full generic types always, all the time. And I drag them along for the ride all the way through to the bitter end. And so you can get things like different kinds of inlining decisions made, or I don't need to do like Java erasure means I have to throw casts in everywhere. And then the Java solution is make casts super cheap. No, that's fair enough. But if you don't cast and you don't need to cast, maybe there's something beneficial comes out of that too.
Trade-off I keep flipping back and forth with things that go megamorphic is, do I want an editor that just like warns me that a particular call site has gone megamorphic? So if I'm a developer and I care, I can think about that. Or does it make sense to have something in the syntax of the language that lets me give the constraint that says, at this particular spot, I know I care about performance. Promise me that this got monomorphized and inlined and treated fast.
Yeah.
And
I mean,
if you fail to do that, then throw an error or at least a warning.
That was goal for AA, was to go there. The Java to C++ to Java experience was that if you required people to say virtual, they didn't. And they tried really hard not to. And then when they threw the virtual keyword in, they had thought hard and really decided it was the right thing to do. And the Java experience was that they then wrote code. The C++ guys wrote a lot of code that would have been really much prettier if they just gone with a virtual route and not cared. And occasionally that didn't optimize well, and then they had to maybe think about it. But the number of times that a virtual Java call was actually the bottleneck for something I was doing, there's like one pattern. It's the hot inner loop does a virtual dispatch pattern because the hot inner loop is pulling data from some virtual place. And almost never otherwise do virtual calls actually give me enough performance that I want it to interfere with my thinking about how to design my program. right? It's like, no, just write this fucking call. Oh, I had an override here. Well, I did. Okay. And then it turns out that 999 point goes here and the 1.01 goes there. And virtual calls do that perfectly. That's inline caches work great. And done. Like I didn't care no more. So walked away. Yeah. It's one of those, I think the right answer is
So your instinct at first is to treat it kind of like the register keyword of we just
Yeah.
don't care anymore.
Yeah,
Just don't.
yeah. I'm okay with having a keyword that says I care, throw an assert. So I could put the register keyword in, and if I accidentally took the address, the compiler will blow on me. Okay, it did or will.
Yeah, that's sort of the generic question that I ask about is the reasonable ways to do compile time asserts that are expressed in the language itself. Like at this spot, I want to know that this function does not do any allocation.
Yes, that's one of the ones I badly want to have that I don't get from any language right now.
And I'm not saying, hey, compiler, force this thing to not have allocation. If it allocates, you just throw an error at me and say, hey, developer, you told me you wanted this thing not to allocate.
And here it is
It
allocating.
does.
Right. Fix it.
Make
Kick
a
keyword out
choice.
or kick the allocation out. Yeah. That's what I want. Yeah, right. All these high performance things that, once you get past, like I went parallel, the next biggest step is you allocated too much. Stop allocating. And why are you allocating? Well, I have to have a hash table and I'm lazily discovering blah, blah, blah. You need some allocations. But you're accidentally allocating, some count of bytes for every byte you read and you're reading a terabyte of data. Well, okay, your life sucks now. Stop.
That was a discussion I had when I first started learning Go, and I was like, how come Go has one garbage collector and Java has like 87 garbage collectors to choose from?
Oh, there's history there. There was a first garbage collector, and it was really bad. And then there was a second one, and by the third one, it was really good. And then people wanted concurrent, and then they wanted incremental, low pause time, and then you get 27. 20 years later, Go looks backwards and can say, people wanted one of two things out of a garbage collector. They just wanted to fucking get it done and go away, or they needed low pause and high throughput and but they didn't need all the flavors and variants thereof. There are a few reasonable choices.
Right. So the early history of Go is people going to the Go team and saying, we have a garbage collector problem. And the Go team responding, no, you have a garbage problem.
Yes.
And almost every time they thought they needed to improve their garbage collector, the answer was what they actually needed to improve was their standard library in such a way that it gave you a pattern to solve these problems without generating oodles of garbage.
That's a good point. Yeah,
and they were like, almost every time someone came to us to complain about the garbage collector, they had actually identified a standard library problem.
That's interesting. Okay. So my experience at Java was different, but I like the Go answer a whole lot better. The Java one was simply, we take all comers and we go to try to improve everyone's life. But it wasn't ever, there was no notion of pushback because you were trying to compete with C. If you pushed back, people, they fuck you and they go off to do C things, right? So you wanted to say, no, we're going to answer, we're going to be everyone to everybody. And we needed to go improve the allocator. And, over many years, when I did all kinds of performance work, the starting point was, don't talk to the allocator. If your allocator is kicking in, you're losing.
So one advantage that Golang had that most languages don't have is most of their early user community had a common manager if you went far enough up the org chart with the Go team.
Right. So one guy.
So there were things where Java couldn't push back because the person they were pushing back at, worked
IBM.
At a different company.
Different company. It was IBM, it was Microsoft.
Whereas the Go team could say, this is our diff. We rewrote your code base to use the new library. Please click OK. We've changed your code for you.
Yeah.
The Java team would have had a lot more trouble doing that.
They did not be able to do that. Yes. And I'll certainly agree that the allocations, there are certain common patterns in the Java standard library that everyone uses that allocate like a fucking mad dog when it didn't need to and almost surely should not.
I mean, how many times on this call have you complained about string.split?
Exactly. That's one of many patterns. It's buffered readline. It's readline. Buffered readline. Allocates. If I'm going to read a billion row terabyte sized file, a billion rows of whatever, and I allocate every time I read every line, I'm dead in the water. That's all your time right there. Fine. And the standard Java programmer, the standard Java programmer, didn't know that for the longest time. I don't know if they still know that, but they just didn't know. So they would just write this pattern. It was the only one the library offered, and it was an obvious pattern to use, and it sucked for performance. And then I come along and say, well, I did this thing, but I had to rewrite buffered readline behind your back. And they were like, how do you rewrite buffered readline? Why would you rewrite buffered readline? Oh, look, it's 5 times faster. We haven't even gone parallel yet, and we're 5x faster. Dude.
Right. So to me, that's going to be almost as interesting as the language design of AA is the standard library design of AA.
Yes. I didn't
how do you really
realize.
build the tools properly so that the number of times I've seen code that looks super weird because they're doing some kind of ring IO thing because they can't afford the number of syscalls that would have been incurred.
Yeah, right.
And it's just like, well, why does the fact that I'm using ring IO to avoid syscalls make my code look ugly? That seems like a thing that you should be able to sweep under the rug of a library.
Yeah. No, there's a lot of library choices that impact performance. Sort of, I'm gonna say not obscure, that's the wrong word, but yeah, I like it. Thank you for that experience. I did not realize that, and that makes total sense to me. Blame the library for a lot of the shit because that's where people are going to reach. And if the library is allocating like a mad dog, maybe it's time to rethink. That's interesting. So what is the Go allocator anyhow? Garbage collector anyhow? Is it just some standard Mark Sweep compact thing? Is it concurrent in any way? Is it incremental in any way? No one knows. Fine.
I mean, I know their whole thing is that they want to have large numbers of small coroutines.
Right.
So I believe that they have at least 2 phases. One that's crawl your own stack and deal with your little marking everything you've got locally. And then they've got a much smaller time that they spend where you've stopped the world.
Okay, but you're still thinking they're stop the world, which is fine. I mean, the Azul allocator certainly has every thread it's running calls itself, and the sleepy threads get called by background people, and then you don't have any stop the world things going on.
It would certainly be fun to have someone who really had looked deep into Go come to give their here's how the Go VM works these days.
Yeah.
I think Zig and Rust are changing a few things where they have function prototypes that only take allocators. And so you can search for all the places that take an allocator are the only places in the code base where allocations happen.
Yeah, Zig is really the kind of at the forefront here because they actually you can't do an allocation unless you have the allocator as a parameter. So you actually if you see a function that doesn't take an allocator, you already know statically that it doesn't allocate. Rust doesn't have this because it has the global allocator. But they are at least kind of going towards that direction.
Interesting. Certainly in the land of C2, there was the notion of an allocator that I was going to pass around for a while, and then I backed off to making it global for a C2 thread, but thread local and whatever. And you went and grabbed alloc from some global. Was it really some global place? I'm second guessing myself. Almost surely I had to grab it from some global place.
Did that force you into places where you occasionally had to make copies of things because you had allocated it to the thread local storage and then handed it to a different thread and now it needed to be moved to global storage?
C2 never handed a different thread. There are a bunch of people yelling about trying to do multi-threaded compilation of the same compilation unit. And I was like, parallel make works great. Why are you bothering? So, you spawn another C2 thread. So there is a farm of C2 threads, and it scales up as things get busy, and it scales down to one sitting idle when it's idle. And the thing that C2 hands out as an artifact that goes multi-threaded is the code blob, which includes all the relocation information and all the dependency information. Like I'm installing a piece of code while I compiled, classes got loaded, other things happen. Is this compilation still valid? And so there is a multi-threaded locking point where you check all the dependencies and confirm, you can't load a class. Are these dependencies correct as they stand? If so, we add them to the global dependency pile, and we put it in the cache, and then we unlock. And now you can load your class, and if you're going to load class, you'll check the global dependency pile. And so there's a locking around class loading and installing code, but that's the first time it goes. That piece goes multi-threaded. The reading side comes weirdly multi-threaded a different direction. One of the fabulous bugs here is that most compilers, including C2, is a giant theorem prover, basically. And if you hand it inconsistent information, it crashes internally, or it proves false as true, and shit hits the fan, right? So if you ever ask a question of the runtime, that question has to be cached. So if you ask it again later, you get the same exact answer. You don't accidentally go to the runtime. How many children classes does this class have? It has one. Oh, I'm going to know that I'm subclassed exactly this thing. Ask again, how many children classes? The answer comes back 2 because a class got loaded. And then at some point he said, I only had 1 subclass for I free downcast you to the child. And the other guy says, no, I have 2. I have to put a test in, and shit hits the fan, breaks. So there is a cache of things you
But that is a
read.
thing that happens.
It used to happen. It doesn't anymore.
There was an old demo I saw, it's got to be 22 years ago at this point, where they would have 2 threads, where one thread was doing the work and the other thread was continuously making new subclasses of a class that was in the first thread. And the whole thing just stops, even though the first thread at no point will ever call or even know about any of these subclasses because they're totally not reachable. But because you keep invalidating the assumption.
That got fixed some time ago. Oh, you're talking he's just invalidating the assumption. No. That got fixed some time ago. That one got fixed as well. So there was definitely one where you got 2 different answers, and then the answers were inconsistent. The compiler would just crash. And that got done by caching. And then the other one is, I ask a question about a validation of something for heroic optimization. I failed some number of times. I start turning off these kinds of heroic optimizations. So I no longer care that you're changing subclasses. I just don't care anymore. I generate code that is invariant to whether or not you have a subclass underneath or not. That was one of many compiler fixes. Another fabulously fun one was the compiler thread was running at the same priority as all the other threads because it was Linux of that era didn't have thread priorities. So you ran a chat channel guy. He spawned 1,000 threads. They chatted each other, all in the interpreter. They kicked the compiler in. The compiler is the 1,001th thread. He gets 0.1% of a CPU time. He never gets a compile done. The benchmark runs interpreted. Right, so the benchmark ends. He's done or timed out where he times, and he turns off all those 1,000 threads, and the compiler jits everything. Too late.
And your fix for that is to give the compiler the top priority?
We had to because
or
we
give
didn't
the
have
garbage collector
threads.
the top priority and then the compiler maybe?
There was no priorities. So we put in, and into hotspot, there is locks and blocks. What do you call it? Chunks and locks and blocks. There is a thread priority faked scheme where we deny Java threads the ability to run if we have pending both GC and compiler threads, and they're not getting their cycles in. We forced a blocking pattern on the random Java threads to make the compilers go. Hand in hand. So we put in fair priorities at some point. So hand in hand with that was we forced all the Java threads to run some. We put in fair scheduling on all threads, including the Java threads. So
my thread wakes up, tries to do real work, sees that there's garbage collector work to be done, and the thread just goes off to do that instead.
No, it would be you had all these threads, and then we decided that this Java thread is running and not letting another Java thread run or a GC thread run or whatever, and we just blocked that thread. So they always had 1,000 threads, but this thread got blocked, and this one, and then 990 got blocked. And then finally, the compiler got to run, and the GC got to run, and people played catch up. And then we started waking up the Java threads, but we didn't let the Java thread run Java or the compiler. I think we tried that for a while, and that had issues with Stack Overflows and shit. So instead, it's the Java thread just gets blocked, and then the compiler thread runs on.
I wonder if it's still there in Hotspot today, because we have definitely seen cases like this where application has, I don't know, 800 threads, and then a deopt happens. The threads are running slow in C1. like updating the profile, everything is super slow, and compiler gets only a tiny fraction of CPU. I wonder if it was just some case that was not handled well, or maybe this whole thing was
You're seeing it
was
recently?
done at some point. Yeah.
Because but this happened in Sun, not Oracle. So a very long time ago. I wonder if something, and then I assume they threw it out when they got priorities. Linux has thread priorities, right?
That's my question. I don't
thought
know.
Linux got thread priorities a decade ago. And the obvious thing to go do is throw out that stupid piece of code and just give the compiler thread some high priority. Same as your GC background threads.
That would make sense, yeah.
And then if it didn't get turned on or it failed to port over or you have OS tweaks and that went away, then you would be back to, I have no priorities, so I'm stuck in. I mean, this was one of the very early chat benchmarks in Java. I'm talking about pre-spec JVM 98 even, like way long time ago. And then the fix was you had to give the compiler a priority, and he wasn't getting it, so you had to turn off the Java threads.
Yeah, but as I said, I don't remember anything similar in hotspot code base. Either I just didn't see it, or maybe it was removed at some point. Maybe in favor of priorities.
And I know we did it. Well, Solaris, I want to say Solaris gave us different thread priorities, but maybe it didn't either. There was a wide issue there. Because we ran on Windows, we ran on Solaris, we ran on Linux. Those were the things we tested on. And actually on my desktop, I routinely tested on Linux. That was my normal dev environment. I don't know. I don't know what happened now. So it could be that you found it again. I know when we went to Azul hardware, Azul OS, that OS had those priorities baked in. That was not a problem there.
Oh yeah, I'm just looking at now. Compiler threads do get near max priority from the list of OS priorities. So I guess that was these just OS priorities superseded what we described.
Right. Yes, that would be my expectation. But now those should work in theory. They should.
Well, I guess with enough application threads, although I don't know how well the priorities work.
Yeah, unless they're just like busted. Like I have totally seen Linux thread counts or the high thread counts be completely busted. So one of the bustages is that they'll run 8 hot swappy threads per core on your 64 core box. So 128 threads will be on the CPUs. Okay, nothing else is running on the box except those. And unless they have a thing that stops them after a while, so they're permanently running because they're waiting for a volatile flag to get set by somebody who has no cycles ever. So unless they get blocked, you wouldn't get a chance maybe to look at a higher priority thread. Like somebody's running in the interpreter, they tickle a count and they bump says, I want to launch or I want to throw a C2 compile out. But they actually have to get to the point where the C2 thread is woken up. Like if they just threw a compile job on a compile queue and then they went right back at it and all cores are all running maxed out and they're all rotating among their 8 best friends, but the other 900 aren't getting touched at all, maybe there's a bug there. Also, well, priorities is a relative thing. I think application can set priorities for their own threads as well. They're not the Java thread priorities, unless they go to native code. The Java thread priorities are supposed to call in the Java thread priority thingy, which lists from a set of like 10 priorities where C2 is above any of the 10, and GC threads are above any of the 10 user pickable Java priorities. That one I clearly remember going in, because I remember seeing the thread priorities be around and we were screwing with them, and then they were like ignored by a bunch of the OSs. Like, yeah, you put priority, but fuck. Fuck you, Charlie. We don't care. Maybe like Linux had priority for UI things, and you could get something going on there. But I remember there were Java application priorities. Now, if the Java guy did native code and the native code said max, and on Linux all maxes were the same max, and you could get hammered. You could also get hammered, by the way. You could do this one. you could get like all processes default to max on Linux. So if you had a really busy set of neighbors and they're like my squeal and they're going to town, they're beating the machine up. Your Java thread priorities were all equal, including the C2 compiler would be at max, racing against my squeal, and my squeal can be hogging the box. That was a known fail pattern. Like I wanted thread priorities that I could run above other guys in the box, but you couldn't do that unless you were root. And you had to be root to lower another process's thread priority. So unless all your neighbors were kindly and chose to nice themselves down, and you weren't root and no one ran root in production, you couldn't stop them from being at max, and that meant they blocked GC threads and they blocked compiler threads. That was the state of the universe when I walked away from trying to solve these problems a decade ago.
Yeah, I think I see it uses near max priority for the compiler thread, and that the enum actually has a reference to Java language specification. So I assume it leaves this max priority like available, and if you can set this priority to an application thread.
Should go to the enums from the Java side and the Java language enums. Java thread priorities. I don't have a source code in front of me, so I'm just doing it from Google laters here. And that should turn into a count of one of like 10 choices that are below the VM's internal max thread priority.
So it looks like it uses the same namespace or the same range for priorities that go up to 10. And it says for internal VM threads, compiler threads, and some others, it says 9, which is near max priority. But I don't think anything prevents Java code from setting max.
Right.
No.
You should be able to set between min and max, which should be like 1 to 10 or whatever the range is. And then the GC and the compiler thread should be above those. Yeah, from the docs, min and max are 10 and 1. That's normal. And I would claim interesting, because the compiler thread should be, he should be above the 10. Yeah, see you, yes, sir. Yeah, we're winding down here. All right, fine. That's a bug for another day.
Could also be a reason to experiment with Linux scheduler and Linux scheduler policies, because sometimes one scheduler is better than other with handling a lot of threads, which end up crowding out another thread.
Right, yeah. Like when I was doing it with Linux thread, there was no choice on thread scheduler policies, and the priority was being ignored, which is why we did our locks and blocks thing.
There is this new thing coming with the sketch ext, which allows you to extend the scheduling policies yourself through BPF. That's gonna, I think, end up quite interesting.
Okay.
There was a mildly interesting debugger scheduler recently. Saw an article about a purposefully bad scheduler that will like make threads wait for uncertain amounts of time and so on to basically make them fail.
Yeah, to test your code, yes. Certainly in the land of multi-threaded anything, we did various kinds of debugging where we caused IO delays and retries and resends and just sleep crap to break things. Yeah. Yes. Bill Pugh has a bunch of work.
I don't know if you've ever tried to Jepsen test a database, but they often rely on very carefully constructed schedulers in order to get it to violate the rules of how the transactions are supposed to go.
Bill Pugh did a bunch of work on perfect forcing of bad interleavings, where he could make test case harnesses that would reasonably
because you want a totally reproducible pathological interleaving
case. Yeah.
Particularly, there's a lot of databases that as time misbehaves.
But
you want to like schedule this thread and then unschedule this thread and then run time backwards by a little bit and then start the new thread.
Wait, you can run time backwards?
I mean, you can certainly set the clock backwards before you schedule the next thread.
Oh, I can't got such cheating for against the database. I think that's not fair.
There's a security company
So
in Maryland, Antithesis, that has a fully deterministic hypervisor where they've abstracted all entropy from a system specifically to test databases or multi-architectural things. Supposedly has some pretty cool results in like Tiger Beetle and other database schemas around.
Yeah.
it's really interesting.
The thing that led Postgres to doing a bunch of their research on clocks flowing the wrong way is the particular use case of you're on some particular machine, the hypervisor pauses you, you get migrated to a new piece of hardware, and the new piece of hardware's clock is earlier than the old because you managed to do a VM migrate faster than the clock skew between the two machines,
right,
and then restart.
And
it was only when Google Cloud got very good at very fast, very low pause time VM migration that suddenly there were all these timing bugs in Postgres.
I actually have a real life case of clocks running backwards just from my day job. So I'm a UI programmer in my day job, and our system is used, for instance, on ships. So if you just cross the international timeline in the Pacific Ocean, you might hop back a day. So yeah, we need to actually like know that kind of stuff. Like, okay, our clocks run backwards. Yes, that's every day.
Okay, fine. So certainly I saw clocks running backwards on the x86 where the tick counter register wasn't synchronous across the different CPUs for a couple generations. And I would ask, and then OS would migrate you, and you'd ask again, and you'd get backwards numbers.
So I think at this point, tick counter is universal per CPU, but not necessarily universal between sockets. If you have two sockets on the same motherboard, you can get migrated between the sockets.
And as a what's the damn Hiram's law rule for Java VMs that not in the spec but is actually required? The happens before relationship you use for all Java locking correctness has to be correct at the very clock where your current time millis changes the low order digit. If you go from a current time millis of blah, 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 01 to 02, at that clock, if one thread reads an 01 and captures it and hangs on to it and hands it to another guy, and another guy picks it up and says, oh, my clock says 02 and you gave me an 01, well, then I have a happens before relationship. But then I can do that transaction in one clock cycle because I can write it down into my L2. You can read it from my L2 and get it in roughly a clock cycle. And at that clock cycle boundary, and I check my current time millis and it's 02 and you gave me an 01, done. So those two have to have a happens before relationship, which means everything that this guy is doing when he writes the time down has to be fensible and prioritized. So this guy reads on the other side, he gets it. And that was a bitch to get correct. So currently in Java, current time millis is not done by reading the tick counter and scaling it. It's done by going to the Linux kernel and asking for that data, which requires you to read some large wad of bits twice in a row to verify they're atomic and then do some math. And that, it turns out, includes enforced fencing that makes it correct.
Yep, that's the conclusion that I've come to by studying distributed systems, is that time is not a thing. Only causality is a thing.
Only causality is a thing. You betcha.
Causality makes it look like there's time, but there isn't.
No, I did the whole Azul thing for a long time. So many cores, so many out of order, not synchronized, whatever. It's just causality. There is no time. Yes. What the hell are you going to do? Fine. All right. What else?
You start learning quantum mechanics and people get really messed up about the fact that there's no like strict ordering of things. It's like, it's fine. There's still causality. There's just not time. There was never time.
Yeah. Yep. Time was all fun and good while we had it.
I wanted to ask about you guys' debugging tools that you guys try and implement. in things ahead of time. I'm still like super early and simple, like chapter 3 or 4.
Oh,
So like I'm very, very early, but I've already, already have like this snapshotting and replaying of stuff working. And I've mostly just been using dot files to compare things, but that's going to have a problem when node
Yeah.
IDs change. I know that.
dot files don't scale well.
Right. exactly. So I'm just curious if you guys had any, like not things specific to a compiler, but what augmented tools like help in the development or
That was
debugging?
you watched me use toString.
Yeah. Okay.
That is really my 99% case. The dot file graphics are fun to show people and get an intuitive feel, but I never use them to debug. I only use the versions of toString. And then the toString has a bunch of interesting, non-obvious things about them. Because a common failure that you get into is that you get toString, so you stop in the debugger and you hover, the toString got called, and you get this great view. toString says, go to all the Java guys underneath, all the nodes and all the types and whatever, and says, please print yourself into a giant buffer. And okay, fine. Well, those in turn call all their little accessors to go get the next pieces of parse of whatever they're going to go do. And somewhere in there, you have accidentally got a caching algorithm. So the act of calling toString is that you cache a bunch of things that you hadn't cached before. And then if you have a failure in your caching strategy where, say, the common one would be union find, you're using targens, disjoint, union find, you need these find calls fucking everywhere. Well, you missed one and you don't realize it. The act of stopping the debugger and calling toString calls the find behind your back. And now the bug goes away. And you run without stopping and you crash. And you stop and you work. So now you need a way to say my toString is entirely functional. But I have recursive algorithms and I have to have bit sets and visit bits and shit like that. So you can allocate in toString, but you can't use like a shared allocation. Like I have this bit set I use whenever I visit things in my graph. You can't then call toString while using this bit set. So the toString guy really wants to say, I'm a private dude. I call the debug version of all the accessors that doesn't do caching. I have a bit set for visitation and an allocation that's all off to the side, unrelated to everything else. So toString becomes this giant monstrosity that pays for itself. For me, it easily pays for itself. If you go to the XKCD, how much work should you spend to go do a thing? A good toString that pops up a fully fledged control flow graph with things neatly scheduled and typed and shit probably saved me 5 minutes of staring at a wad of lines of nodes. Okay, I do that 20 times a day. You go do the math, and I could win on that if I spent months and months on toString. So it's definitely a high payback to go spend a week on toString, and you'll spend 1 week now and 1 week scattered throughout the next year while you find all the places where you fucked up toString. But
Sure.
toString for the win.
Very cool.
I will add that in addition to that, which I all agree with, that I get I get a lot of mileage out of the graph clones that I make as I'm peeping, but that's also because I'm working with a REPL. So when I do a compile, if it crashes, I'm sure that I've got a live reference to the current graph, even if it crashes, so then I can start looking at it. And then I can poke away at it, and I can actually go back. I can rerun a peep, add a point in history. I can call functions on things like, say, why did type give me this? Call the type and step through it at that point in history and stuff. And yeah, you can also do that by setting the right breakpoints and stuff. But I don't know. I like this workflow. And then the other thing that I do is I have a way of, so when I do a snapshot, it's based on a peep happening, and I capture which nodes were involved in that peep, at least the one that triggered it, and usually the return one. And then I can do a little miniature graph visualization of just the nodes that were on the peep and their immediate neighbors. So like basically I look at all the neighbors of the node that I'm interested in, but then I don't necessarily render any of their neighbors. So they're kind of partial nodes rendered. And then, but then in the function that produces that, I can give it extra IDs. So if I'm interested in some other nodes, then I just say, oh, and this ID and that ID and that ID, and it does them all against that snapshot. And so I'm able to fairly quickly look around through the graph. I have like different tools for viewing it at points in time, viewing different sets of nodes, whatever. And I find it pretty useful. Like it does a lot of, for me, what the toString stuff does for Cliff, and especially once I get the graph nice and small, then it's really understandable, and I just render it how it makes sense for me, and not necessarily very easy for Cliff to like look at the graphs that I render.
But your graphs and mine look different, so
they look very different. And I don't actually respect edge directions. I tend to draw edge directions the way that makes the graph renderer happiest. So, and then I just know that, oh, these ones are going to point that way, these ones are going to point the other way. And that's confusing for everybody else, but it's fine with me because I'm used to it.
I think
it's for me.
So I have strategies for those kinds of events as well, like how far deep to print in the debugger and the quick turnaround in the debugger, so I can just go print again.
Yeah.
But I think the takeaway there is you're going to spend some time on debugging tools, and you define a workflow that you can live with, that you're going to use all the time.
Yeah, and you mentioned that your IDs were changing or something. Like, I don't know.
Live ranges are changing, not the node IDs.
Corey mentioned, I think, that in his snapshots, his IDs are different or something. Like,
they haven't yet. I anticipate with future larger unit tests, if I change peepholes, that the prior unit tests might fail if I'm relying on IDs. Maybe not. Yeah. But that's kind of what I'm anticipating, at least.
Right. I see. Yeah.
So within a compilation, I don't change node IDs. I tried that a few times in C2, and it's really gruesome because you can't cross the boundary reliably.
Yeah, but it's definitely a problem with tests that the IDs change.
Yeah.
I've experimented with different ways of doing it. I did actually in the previous compiler I had a lot of golden tests, and I eventually got really sick of constantly updating them for this exact reason.
Yeah.
But it's not the only reason. Also, node orderings will change in a not important way.
Right.
So I ended up doing something which was basically like heavily strip out ID or like replace IDs, so that I took all the nodes and I sorted them different ways, and then I started generating IDs that would be stable, that were just for the test prints, so that I could trace around through the graph, and the test print had these IDs which were not related to the nodes in the graph. But that was annoying for debugging, but it kept my tests pretty stable.
You nailed it there with test print. I long ago got to here's my debug print. It shows me node IDs all the time. Here's my test print. It's different. It strips a lot of the shit out, so I don't have the golden test problem. So you end up with 2 prints. Oh, I'm doing dot graph output. Now I have 3 prints. So I'm just saying, be prepared to stack a bunch of these and think about them when you're designing yourself in your corner there.
Yeah, I mean, I'm very much. I mean, I think creating the augmented tools is half the fun of this kind of stuff, right? So that's pretty cool. But yeah.
Yep.
You guys have years of experience, and I'm just like, what else? What else do we not talk about that just kind of is in the hive mind?
All good. So I'm on Discord. You can ask there too.
Yeah, 100%. 100%.
All right, I'm going to call it.
One comment on this. There's a flip side to the golden test, is that you can generate the same output, but have your checker be generalized. So that's what LLVM file check does. It does allow you to write very generic tests, like you can check in any topological order.
Yeah.
The instructions are just going to appear. And this is very useful for testing instruction schedulers, because instruction schedulers in the backend very often tiny change completely flips the order of instructions. But that doesn't matter, because if you are only testing that the DAG is still a DAG, then that's going to be correct. So otherwise you would have to update this test like on a daily basis or something. So I think that there's a high value in generalizing your checker and your golden test, not necessarily changing the output to diverge from the regular output.
Yeah,
That's a good idea.
I'll certainly agree. I'm looking for the right answer for the register allocator, which at the moment is counting some estimation of spills. And then there is a checker to be written to validate that I still have the correct USDEF edges when I'm done. But I don't have otherwise a good answer on the allocator to correctness versus performance. It's both. It's both correctness, but it's also performance. So it doesn't spill crazy. All right. Till next week.
Bye.
Bye.